All right, good morning, afternoon, good evening. I hope everyone is doing great. I want to go ahead and take a look at the new theorem that we're going to be looking at. I don't know why that just went off. There we go. And that's the hypotenuse leg theorem. Now, what I'd like you to do on your paper is to go ahead and draw two right triangles for me, just so that we can kind of see what's going on with the hypotenuse leg theorem. So I'm going to go ahead and draw two right triangles. And I'm going to label these side lengths 3 and 3 and 5 and 5, okay? And I want to go ahead and mark both legs congruent and both hypotenuses congruent, okay? So what that tells me right now as I look at that problem is that I don't have congruent triangles. From what I already know, from previous experiences proving triangles, I don't have side, angle, side. I don't have side, 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 angle, or angle, angle, side. But what do I have? Well, I have angle, side, side. Ooh, that's the big no-no, right? We do not want to prove triangles congruent using that justification because it's not always true. Sometimes it is, but it's not always true. So then I start to ask myself, is there a way that I can kind of work my way around this triangle that would allow me to state these two triangles to be congruent? Well, in that case, maybe I look just at this triangle over here, okay? And I start to ask myself, maybe there's a way to figure out this side length. We've talked about this year. We've said, well, if I go ahead and do a squared plus b squared, won't that equal c squared? And when I know two of the three sides of a right triangle, can I figure out that third side? And the answer is yes. Now, if you don't already have this marked down in your vocabulary packet, you might want to go ahead and show this, the sides of the right triangle. Okay? The sides of the right triangle consist of a hypotenuse, okay, consists of a leg, and it consists of another leg. And so as a result, I have the Pythagorean theorem here, and I can plug things in. And so if I do that, I end up having 3 squared plus b squared is equal to the hypotenuse squared, okay? Now from there, I should be able to figure out the other leg length. And so if I do this, 3 squared is 9. The hypotenuse squared, 5 squared is 25. And if I go ahead and subtract 9 from, or no, I put 6, subtract 9 from both sides, I get b squared is equal to 16. And I can square root both sides to get the square root of 16, so I know b will equal 4. Okay? So I know that this length right here is going to be a length of 4. All right? Now, from there, I should ask the question, in this other triangle, if I do the Pythagorean theorem, will I get the same answer? And the answer is yes. I'll get 4 right there. Okay? And so we can see that those triangles are congruent, right? By what reason? Well, we have side, side, side. All three sides of the one triangle are congruent to all three sides of the other triangle. So I have congruent triangles, side, side, side. Or, thinking, I have side, angle, side, don't I? Because of the congruent right angles. Okay? So with that being said, I know my triangles are congruent. So I want to back up and I want to ask the question, what was the least amount of information I needed in order to prove those two triangles congruent? And the answer is this. I needed a pair of hypotenuses congruent and a pair of legs congruent within that right triangle. Okay? And that's where we get the hypotenuse leg theorem. Okay? So, on your vocabulary sheet, you want to pull that out and write down the hypotenuse leg theorem for me, and I'll read it off to you on your vocabulary sheet. Okay? So here's what the hypotenuse leg theorem says. If the hypotenuse and a leg of a right triangle, so again, if the hypotenuse and a leg of a right triangle. Now, if I were you, I would put a box around the word right triangle because that's really key here. Because without a right triangle, you don't have a hypotenuse. Okay? So if the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, and again I would put the words right triangle in a box, okay, to highlight that, comma, then the triangles are congruent, okay? So if that was too fast, which I'm sure it was because I went through it kind of quickly there, rewind it, write it down for me. That's your hypotenuse leg theorem. Now the next thing we're going to do is we're going to take a look at a couple of examples here just to make sure that we are good with everything that we've been talking about. So here's what I'd like you to do. I'm going to go ahead and go up to the top here. Where are we at? Right there. First problem. Okay. And at the very top of your paper here, I want you to go ahead and write this down. The hypotenuse leg theorem. Okay. And there are 3 requirements that you need to meet in order to do the hypotenuse leg theorem. Okay. And these requirements, I'm going to be looking at these requirements as we work through the proofs. Okay. The 3 requirements, the second and third, I think everybody knows. All right. You need to prove it congruent hypotenuses. Okay, you have to prove a pair of congruent hypotenuses. So that one should make sense, hypotenuse leg theorem, right? And you need to prove a pair of congruent legs. Okay? Duh, hypotenuse leg theorem. All right? Should make sense, correct? And again, here's where most people mess up. They forget that in order to have this right here, they have to have right triangles. Okay? So, in looking at our first proof, the first thing I would want us to do, and I'm going to change colors here so I don't get too much red on my paper. There you go. Okay. I want to look at this first part right here. CD is congruent to EA. Now, if those are right triangles, which we have not proven them yet, but if they're right triangles, CD and EA would have to be what parts of the right triangle? Well, they would have to be the hypotenuses. So I've already got this requirement met. That's good. I don't have to do any more work with that. But I have to get the other 2 requirements. So what I would probably do is I would probably focus in on what's being given right now. And the given says this, that CD is the, what's that right there, that upside down T? Well, I hope you're thinking perpendicular, okay? And so as we think perpendicular, what are your first thoughts that come to your mind? Well, it should be that they intersect to form right angles, okay? And so I'm going to go ahead and say this, if AD is perpendicular to CE, if this segment here is perpendicular to this segment here, then this angle, this angle, this angle, and this angle all have to be right angles, okay? And so I'm going to go ahead and put this down. Angle CBD and angle EBA are right angles. Okay. Now, how did I come to that conclusion? How did I know that to be true? Well, the reason is this. I know what perpendicular means. I know that any lines that intersect to be perpendicular have to form right angles. So I'm going to put this down. Definition of perpendicular. Remember, what occurs here, I'm going to translate there and put my justification over there. Okay? So I'm going to go over here to my picture and I'm going to put right angle, right angle. Okay? Now, for most of you since probably 3rd grade, if not sooner, you guys have known what type of triangles those 2 triangles will then be, right? You know that when you have a pair of right angles, you have what type of triangles? A pair of right triangles. So the next thing I'm going to do, because I have to still prove this, okay? I'm going to go ahead and say this. Triangle CBD and triangle EBA are right triangles. Okay? Now, how do I know that they're right triangles? Hopefully you're thinking this. Definition of a right triangle. You've known since 3rd grade that if you have a right angle, you have a right triangle. Where did that come from? Because you knew the definition of a right triangle. Okay? So as of right now, I can mark off that part right there. We've got 2 of the 3 requirements. We're on the home stretch, folks. We've got to finish it up, though. The last thing that we need to prove in order to prove the triangle's congruent would be this. Bisector. We're going to bisect CE. Okay? So we're going to say that AD, this segment here, is bisecting or cutting in half this segment here. So what's the result? What's the result of CE being bisected? Well, it means that if we're bisecting a segment, which we are here, it means that we have 2 equal segments. This segment here is equal in length to that segment there. Okay? So I'm going to go ahead and say this. CB is congruent to BE. And the reason is going to be this, definition of bisects. Okay? How did I know that those 2 segments were going to be congruent to each other? It's from my understanding of what the word bisects means. Okay? Now, as you look up there, I have a pair of right triangles. I have a pair of congruent hypotenuses. I also have a pair of legs congruent. And so from there, number 5, I can state that these triangles, CBD and triangle EBA, are congruent by hypotenuse leg. Okay? It's got to be there. Those 3 requirements. If we don't have those 3 requirements, we don't have congruent triangles. Okay? All right. Let's actually, I'm going to go ahead and erase what we've done here. I'm going to leave my 3 requirements up there. Okay? Erase those off right there. I'm going to erase this. And let's go down to the next proof down here. And see if we can figure out how these 2 are going to be congruent to each other. That's not going to work, is it? I wonder if I can pull this. Can I pull this? Oh, I can't do that. That's not good. Oh well. I may have to erase this too. Okay? Just keep that on your paper right there, and I'll refer back to it. I just won't have it written down up here, even though I wished I could have it written down. Okay? Now what just happened? Did I just close that out? All right, I got to pause this because I think I just closed out my Word document. All right, sorry about that snafu there, folks. I'm not sure why that closed out for me. It's, you know, technology. You get going and all of a sudden you hit the wrong button and you've lost everything. So, all right, so looking at this one, you still should have those 3 requirements at the top of your paper there that we have to meet. And so as I look at this problem, as of right now, what requirements have we already met? Well, if I look at WJ being congruent to KZ, WJ is congruent to KZ. If those are right triangles, those would be the legs. So I've already got a pair of legs congruent to each other. From there, I think that most students from this point would probably do what's easiest, and that's completely fine with me. I would do the same thing. I would mark the reflexive property to be congruent. So let's go ahead and put that down. JZ is congruent to JZ, not to be confused with the wrapper, okay, by the reflexive property. And I'm going to go ahead and put that down, okay? Now what would that be within the right triangle? Well, those would be the hypotenuses. So right now we've got the pair of legs congruent, we've got the hypotenuses congruent, but in order for those to be hypotenuses, we have to have a right triangle, okay? So the good news is this. I already know that I have right triangles because those are right angles, right? I just have to go ahead and state that. So for the third step, here's what I would put down. Triangle JWZ, triangle JWZ, and triangle ZKJ are right triangles. Okay? Now the reason they're right triangles comes from our understanding of what a right triangle is. If you have a right angle in it, you have a right triangle. So I'm going to put down definition of right triangle. All right. Now, I have a pair of right triangles congruent. We just proved that. I've got a pair of legs congruent. I just proved that. I've got a pair of hypotenuses congruent. I've proven that. So to finish things off, what do I need to do? Well, I've hit all three of those requirements for hypotenuse leg. And so from here, I would just do this. Triangle JWZ is congruent to triangle ZKJ, and I would put down hypotenuse leg. But again, you recognize what I did there. I went through all three of those requirements. A pair of legs congruent, a pair of hypotenuses congruent, a pair of right triangles. I'm done. Okay? All right, let me show you one last one just to make sure we've got this down. And here's what I would do for this one. You've heard me say this in the past, and I think that there are some students that do this. I would say the majority probably don't do this. But if you're serious about wanting to master the proofs here, I would definitely turn your computer, or I would pause your computer, and I would see if I could go ahead and solve the middle proof on the back side there. Okay? I'll even give you a hint. It's got 5 steps to it. If you can do the 5 steps, you should be good to go with any of these types of proofs. Okay? So I'm going to pause here. You go ahead and do it. Make sure you pause me, and then come back and see how well you did. Okay? All right. Hopefully you pause it for a couple minutes there, and we're able to try to figure some things out. I think most students in solving this proof probably are going to do the easiest thing first, kind of like on the last one. And I'm probably going to say MJ is congruent to MJ by the reflexive property. Okay? All right, and then I would probably go ahead and mark that in my diagram. And that's good. The next thing I would probably do is I would start to look at what I have and how to solve it from there. So what I have is part of the given, and I look at this, perpendicular lines. Well, what does that mean? You know, in a class I had earlier today, what they did on that one was they went ahead and jumped right to the fact that with perpendicular lines you have right triangles. Okay? Now I'm standing in a room right now that has ceiling tiles in it, and they're all rectangular in shape. And if I was to say that I think they're metal strips that hold the actual ceiling board in place, okay? But if I was to tell you that those metal strips intersect and are perpendicular to each other, you would interpret that and say, okay, there's a right angle there, okay? You wouldn't interpret that and say that those rectangles are right triangles. No, okay? A rectangle does not look like a right triangle. They're two totally different objects. And so when I tell you that these lines are perpendicular, kind of like I tell you that the metal strips on my ceiling intersect perpendicularly, okay? You shouldn't be thinking right triangles. It will lead you to right triangles, but you shouldn't automatically jump to the assumption that you're working with right triangles. So what I'm going to do here is I'm going to say this: angle MJN and angle MJK are right angles. Okay? And what led me to that understanding? It's my definition of perpendicular. Okay? Perpendicular lines lead me to the understanding of right angles. They don't lead me to the understanding of right triangles. Okay? Now that I have right angles, that leads me to right triangles. So the next thing I'm going to put down is triangle MJN and triangle MJK are right triangles. Okay? How did I know that? Well, my definition of right triangles tells me that with a right angle you have to have a right triangle. Okay? And then from there, I want to go back to my requirements and make sure I've hit all of my bases here. If I've hit all my bases, I should be good to go. Do I have a pair of congruent hypotenuses? I do. Do I have a pair of congruent legs? I do. Do I have a pair of right triangles? I do. So now I get to prove the triangle's congruent. So triangle MJN is congruent to triangle MJK by hypotenuse leg. Okay? All right, folks. I hope that wasn't too confusing. I hope that you understood all of it. We're going to continue to practice this so it becomes sort of second nature to you guys. We're not going to, throw you into a test or quiz and expect you to know that right away. But we do have a quiz coming up, so make sure you understand these proofs. If I was to summarize hypotenuse leg, I want you to memorize the 3 requirements that you're going to have to know. The right triangle, the pair of hypotenuses congruent, and the pair of legs congruent, and then be able to apply that to the problems that require that. Okay? So again, I've told other kids this in the past. This is the one type of way to prove triangles congruent that students always forget about. Okay? We remember the side angle side, the side side side, the angle angle side, and the angle side angle, because they all have an angle or a side in it, but hypotenuse leg is one that we easily forget, so don't do that for me. I want you guys to have a great night, and I will see you the next time I see you. Good night.